So let's take a look at chapter 8. 8.1, this is basically just the basic principle of hypothesis testing. So if you look at this thing here, it's just like a science experiment, right? Before you do the experiment, you have to put in the hypothesis, right? A little bit different in terms of this thing here is we come up with the hypothesis, and then we will see if the hypothesis that we come up with is it true, or if it's not true, then we will throw that hypothesis away, okay? But if you look at this example here, this is the example in the beginning of your chapter 8 textbook, in the textbook of chapter 8, right? A study published in the Journal of Air and Waste Management Association report that the mean amount of particulate matter produced by the car and the light truck in the open setting is 35 milligram of the PM per mile travel. Suppose that the new engine design is proposed that the intent to reduce the amount of PM in the air. So again, if you create this engine, you have two outcomes, which is this engine either be successfully reduce the PM in the air, or they cannot, right? So again, that's the idea here is we come up with something, and again, there will be that distribution table or a binomial distribution, which is either come out to be what you want it to be, reduce the item, or it will be failure and it doesn't, right? So that's what we have is because there are two outcomes, we will have for us, we will have two hypotheses, okay? So the first hypothesis, we call this a null hypothesis, or you will hear me say that this is the dummy variable and this is the dummy hypothesis, okay? So again, the null hypothesis and the other one we call a alternate hypothesis, okay? So for the null hypothesis, it's basically tell you that the parameter, which is some number that represent the population, is equal to a value. Whatever the value we have, in this case, if you look at up here, well, before that, our notation for the null hypothesis will be 8 sub 0, okay? So again, the null hypothesis will be 8 sub 0. And this thing here, if you look at this example up here, to identify or to state the null hypothesis, which is, this is what they tell you, that the null hypothesis state that the parameter, which is in our case, the parameter is the mu, which is the number that represent the population, right, is equal to a specific value, which is a sample mean in this case, okay? So this is what we have is, and one thing I tell my student, and the reason why I say a null hypothesis is a dummy variable is because the null hypothesis can only take on an equal sign. The only notation or the only item that the null hypothesis, when you put in a null hypothesis, is can only be equal to whatever the number is, okay? So again, look at this thing here. So if the null hypothesis is 8 sub 0, what would be the alternative or alternate hypothesis? So again, the notation for the alternate hypothesis is 8 sub 1. So again, 8 sub 0 is the null hypothesis, 8 sub 1 is the alternate hypothesis. And the alternate hypothesis will take on 3 different possible outcomes, right? Which is, again, the null hypothesis, as you will see, that if your claim, which is, I will tell you a little bit later, if your claim state that is less than something, then your null hypothesis will be, again, a mu is less than some number. So if on the previous one here, which is we want to reduce the PM, which is the mu will be less than 30 milligram, because we want to reduce the amount that the engine released, right? So again, reduce them, make them less than the 30 milligram they have, which is the mu will be less than the number, the specific number, which is the 35. And again, this thing here, because it's less than your inequality point to the left, we call this a left tail test, which is, you heard me say it last time, a left tail, a right tail, one tail, or something in that nature. This is where it's all coming down to, okay? So again, if your claim, or if you try to prove something that is greater than, which is greater than tell us that we use a greater than sign, which is the greater than point to the right. We say that this is a right tail test. Okay, and again, the other one is if it's not equal to or if it's not the same, then again, how do we illustrate that it's not the same or it's not equal to? Well, it can be smaller than or can be bigger than the value. So the only thing we say that, again, as long as it's not equal to 35, we're good to go, which is we just put an equal and put a line through it. So again, because there's a equal and a line through this, which is not equal to, we say that this is a two-tailed test. The reason why it's a two-tailed test is because the number can come out to be smaller than the actual number, or the number can come out to be larger than the actual number we have. So we don't care as long as it's not the same, which is it can come out less or can come out bigger than that's why we have a two-tailed test. Okay, so again, the first thing that you want to remember, or the first thing that I want you to take out of 8.1 is when you state the hypothesis, and this is what you will do a lot, is to state the hypothesis. The H sub 0, which is the null hypothesis, can only take on an equal sign. The H sub 1 can take on 3 different signs depending on what your claim is. It can take on the less than, it can take on the greater than, or it can take on the not equal to, right? Again, each of them is individual. There's no way that you have one problem and both of them is together, okay? If both of them are together, like number 1 and 2, we say that is number 3, which is the two-tailed test, okay? You will never have a right tail and a two-tail together. You will either have a left tail, a right tail, or a two-tail, okay? So let's practice this thing here. Let's say, how do we state the hypothesis, right? So if you look at this thing here, number 1, they say last year's the mean amount spent by a customer at a certain restaurant was $35. The restaurant owner believed, again, this is his claim, he want to believe, I guess, he believed that the mean might be higher this year. Okay, suppose that, again, and now they ask you state the appropriate null hypothesis and the alternate hypothesis. So looking at this thing here, like I mentioned to you guys, very easy. The null hypothesis is H sub 0. And H sub 0 is a dummy hypothesis, which is the reason why it's a dummy hypothesis because it can only take on an equal sign. You will never put any other sign in the null hypothesis based on this author and this book. Okay, so again, other author, they use different method. For this author, he say that to keep it consistent, the null hypothesis, the H sub 0, will only contain an equal sign. So again, what is this mu equal to? What is the mean equal to? Well, the mean is equal to 35, which is, again, that is what we have. We want to say that, again, the mean of the amount of the customer spent from last year is $35. So we want to say that the mu is equal to 35. Now, the alternate hypothesis will be H sub 1, which is H sub 1. Again, we still use the mean because we want to, because our problem relates to the mean, right? And again, the owner believes the mean might be higher. What does it mean, may be higher than this year? So again, do you agree higher mean greater than? Which is do we do? Well, do you agree that this is what we have is the mean? Whatever the mean is, have to be bigger than, greater than, higher than 35. So again, this is your alternative hypothesis or alternate hypothesis, which is, again, mu is greater than 35. Okay, and that's it. That's all we need to do to state this hypothesis. And again, we haven't done any testing yet. Right now, we're in the process. We introduce you what the process of the testing and how the testing out or how the result will be. Okay, but before we do the testing, we have to know how to state the test. So again, to state this thing here, go back one more time. Again, the null hypothesis will only take on an equal sign. It depends on what the claim, depend on what we state in the problem. It can be greater than, can be less than, or can be not equal to. Okay. So now looking at this thing here, number 2, in a recent years, the mean weight of the newborn boy in a certain country was 6.6 pounds. A doctor wants to know whether the mean weight of the newborn girl different from this. State the appropriate hypothesis, right? So looking at this thing here, we know that looking at this item, we know that he wants to know, he don't want to know if it's smaller than or less than or greater than or bigger than the 6.6, right? He just want to know, is the baby girl weight is different, not equal to. Everybody see that? So if you look at this thing here, well, let's go with the null h sub 0 first. Well, h sub 0, do you agree that h sub 0 can only contain an equal sign? And if it's only containing equal sign, what does the mean equal to? Well, the mean is equal to what is ever the weight that they give us, right? Whatever the sample weight that they give us. So the sample of the newborn baby boy is 6.6 pounds. So the mu is equal to this sample, which is, we assume that is equal to the sample, which is 6.6. So what is the alternative, or alternate hypothesis? Well, looking at this thing here, hopefully you see that, oh, because we're looking for something different from the 6.6, if it's different from the 6.6, we just say it's not equal to 6.6. Again, it's different. It can be 6.5, which is less than 6.6, or can be 7.1, which is greater than 6.6. As long as it's not equal to 6.6, then it's different from 6.6. So again, just like any other problem, right? Your goal is you want to see what's the key word to know. And again, if it's not equal to, not the same, or different, then that's not equal to. If it's greater than, more than, higher, above, those are the things that you use the greater than sign, right? And again, the last thing we have, if you look at number 3, they're looking at this item here. Again, the mean number of miles per gallon the car with a small engine is 25.5, which is, again, this number is related to the small engine sample. The engineer think that the mean car with the large engine will be less than. Again, what is mean less than? Which is less than, just like the word, which is we're looking for something less than this number 25.5. So in this case, the null hypothesis will be h sub 0 will be mu equal to 25.5. And again, that's why I call it a dummy variable, because it can only take on an equal sign. And the alternate hypothesis will be mu will be, again, because it's less than, I have to say less than 25.5, or in the sense 25.5 is greater than the mu. But in this case, again, the mu is less than 25.5. And again, they will ask you, the follow-up question is, they can ask you if number 1, what kind of testing do we have here, which is we have a right tail test, because the inequality point to the right, we say that this is the right tail test. What kind of testing for number 2? Because if it's not equal to, this is a two-tail test. And again, because the inequality point to the left for number 3, then we say that this is a left tail test. Okay, so those are the questions that will ask you in 8.1 is, can you state the null hypothesis, and can you state the alternate hypothesis, which is h sub 0 and h sub 1. Okay, and again, the value that they will give you in the problem, that will be the value that you will use here. Okay, so question with this thing here, how to state the null hypothesis and how to state the alternate hypothesis. All right. So one thing is, the reason why we need to state this thing here is because this is what we do in terms of the hypothesis testing, ladies and gentlemen. So the purpose of this hypothesis testing is basically, the first thing we need to do is, again, even though I say the null hypothesis is a dummy variable, but the first thing is we need to assume that null hypothesis is true. Okay, so the first thing is we will assume that the null hypothesis is true. And then what we do with this thing is we go in and we try to gather data, we try to find the data, and to see that does this thing contradict what we try to assume. We try to assume it's true, and then we go to looking for the evidence to contradict that. If we're able to find the evidence to contradict the trueness of the null hypothesis, then we say, well, we were wrong. We assume you are true, but we're wrong. So therefore, you are false. Okay. So just like as you can see on the screen here, it's just like a criminal trial, right? If you go to any trial, is innocent until proven guilty, right? You know, everyone stay in front of the judge, have a innocent until proven guilty. So it's just like that criminal trial, right? You go in, you are innocent, and then your side and their side, they put out the evidence. Whatever evidence holds stronger, then that will be, again, your side will try to prove the innocent, the other side prove that you are guilty, which is, again, if the evidence hold up and then they found out that you are guilty, then again, we say that you are no longer innocent, right? So again, and that's the idea of the hypothesis testing, is we assume that it's true until we prove it is false. Okay, so just same thing is we assume that innocent until we proven you are guilty. Okay, so again, in the sense of that, that's what we try to do in this testing. Okay, so for now, let's take a look at that. This is what I mentioned to you guys is, again, the first thing is we always assume the null hypothesis is true, and then we go in and we try to look for evidence. And once we find the evidence, if the evidence hold, this is what we have, is we will say that we will reject the null hypothesis. Okay, so again, the second thing we have to do is, once we have the evidence, or how do we state the conclusion? Okay, so once the first thing is we have to state the test, we have to give you the H0 and the H1. And then we go in, we do all the testing, and then whatever the result from the testing is, which is that what we're going to do next week, 8.2, 8.3, 8.4, whatever the result from testing is, we come out with the conclusion. So the conclusion is this, ladies and gentlemen, we only have two conclusions. You don't have any other conclusion besides this two conclusion. Is if you find enough evidence, you will reject the null hypothesis. You will say, we will reject H0. And if you reject H0, you will say that you have enough evidence to support whatever your claim is. And again, the reason why I say claim is because most of the time, or for this author, the author using the claim in H1. Whatever the claim, as you can remember, the owner want to claim that the mean is higher this year, right? So that's his claim, and his claim will be in the alternative or alternate hypothesis, which is the H1. So if we throw away the null hypothesis, then we have to accept the H1. Okay, so and mostly H1 is your claim, and we say that most of the time you will say that we have enough evidence to support whatever you want to support. So that's the first outcome. The first outcome is we reject the null hypothesis. The second outcome is we do not reject the null hypothesis, or we fail to reject the null hypothesis. And if you fail to reject the null hypothesis, all you're going to say is, we don't have enough evidence to support the claim right now. Okay, we will never accept the null hypothesis. Okay, we assume it's true, and then we prove that it's false. Okay, so we will never say we accept the null hypothesis. You will either throw the null hypothesis away, or you cannot throw it away. You do not reject, or you fail to reject. But if you fail to reject, all you're saying is, we don't have enough evidence right now to prove whatever we try to prove. We will go back, gather more evidence, and we'll come back another time. Okay. So, and again, to go back to that criminal trial, right? When they say the verdict, they say you guilty or you not guilty, right? They never say you innocent. We don't know if you're innocent or not, right? Then they say you guilty or we found a defendant guilty or not guilty. Because again, we don't know if you're innocent. You might be innocent, right? But we cannot prove you're innocent, right? We can only prove that you're guilty or not guilty, okay? So that's why we will never accept the null hypothesis, because we assume that it's true, so we will never accept that, okay? So again, just the same, you know, the same I tell my student is, for instance, if you argue with someone, right? And someone states something and you say, okay, look at this. I found this. All of this thing here prove your argument is wrong. And then the other person will say, okay, okay, you got me. But if you don't find enough evidence, this is all you're saying is, I don't know if you're right or not. For now, I don't have enough evidence to say that you are wrong. I will come back later when I have more evidence and I tell you wrong. So just hold right there. I'm not agreeing with you. Just right now, I don't have an evidence to say that you are wrong, but I'm not accepting your proposal in the sense of that. So that's what the hypothesis testing is. We assume, and then we try to contradict that. Okay. So again, just go back that you have only two options. You either reject the null hypothesis or fail to reject them. You do not say anything else. You either reject them, and like I say, if you reject them, you would say we have enough evidence to support whatever we want to support, or the claim. And if you fail to reject, you just say we don't have enough information right now. There is not enough evidence to conclude what we want to conclude. Okay. So question with this two conclusion here. Now, let's take a look at this thing here. And again, so for instance, let's take a look at this item. And let's say if we have this item here, how would your conclusion be, right? So again, a box of cereal, of a certain kind of cereal or label on the box is containing 20 ounces. An inspector thinks that the mean weight might be less than this. So again, his claim is less than 20 ounces, right? The manufacturer lie, right? The manufacturer say it's 20 ounces, but he think that they contain less than 20 ounces. So now let me ask you guys, looking at this thing here, before we state the conclusion, what will be our test? What is my null hypothesis? Again, if you look at this thing here, do you agree that the null hypothesis, your dummy variable, will be the mu, which is the mean, because we deal with the mean is equal to the 20 ounce, right? And if the mean is equal to 20 ounce, and he assumed he want to test and he want to prove that the manufacturer is lying to his company and they put less than 20 ounce, which is, do you agree that our alternate hypothesis is the mu is less than 20, right? I don't know why I hide up here and I did not hide down here. It's the same question. But again, looking at this thing here, that is your testing item, right? So now they ask you this thing here, and again, this is your statement. Your statement is, again, mu is equal to 20 versus mu is less than 20. He go in, he did the testing, and then he came out with the conclusion he reject H naught. Again, what does it mean? Reject H naught, meaning, again, you can throw this thing away. You reject H naught. You throw the null hypothesis out. So if you throw the null hypothesis out, meaning you accept, wrong item. Meaning, again, we never say we accept, but again, in theory, if you have only two options and you throw one of them away, meaning you have only one option left, which is you have to take this option. And your option, if you take this option, do you agree that this option right here, the mu is less than 20, which is the same as he claimed? He claimed that the mean is less than 20, right? So again, this is his claim, the inspector claim, and that is what we got. So if we reject, if we throw the H naught out, we say that, again, we basically say that we have enough evidence. So basically, this is all you state. This is your conclusion. Your conclusion is we have enough evidence that the mean weight of the cereal box is less than 20 ounces. Again, all this thing up here is just the same thing I mentioned to you guys is, since we reject the H naught, meaning we throw this thing out, and if we throw this thing out, we have only the alternate hypothesis left to consider, and that happened to be our our claim. That's why we say that we have enough evidence to support this claim that the zero box is less than 20 ounce. Okay, so if you look at on the bottom, everything is the same. The only thing different is he cannot reject the null hypothesis, right? He cannot throw away. He failed to reject. He do not reject this thing here. So the null hypothesis is this thing here, and he cannot throw it away. He cannot prove that this thing is wrong, right? So if we cannot prove this, if we cannot throw this thing away, we don't say that this thing is true. We did not prove the trueness of this item. We try to prove the falseness, right? So we try to prove that this thing is false. So we did not do any test to prove this thing is true. So we cannot accept this thing here. So the only thing is, if you cannot throw it away, which is you do not reject them, then all you're saying is this, which is if you don't reject them, all you're saying is we do not have enough evidence that the mean weight of the zero rock is less than 20 ounces. Basically, we don't have enough data yet. Give me a few more days, let me collect more data, let me do more testing, and when this number come out different, I come back to you and I say you are wrong. Okay, so basically that's all you're doing here is if you reject the H naught, you say you have enough evidence, he lying to you or whatever the item is, right? And if you cannot reject, you do not admit defeat, right? It's weird, you do not admit defeat, you just say we don't have enough evidence for now. Okay, so basically that's what the conclusion is. Okay, the conclusion, like I say, to go back, if you reject, you have enough evidence. If you do not reject or you fail to reject, you don't have enough evidence. Okay, so question with this thing here, how to conclude, you know, how to state your conclusion. Any question of how, again, right now, just know that you have two outcomes, knowing that you either reject the H naught or fail to reject the H naught. I say fail to reject H naught a lot because when I learn, the book that I use is fail to reject. And I think this book, I think he used do not reject a lot more than fail to reject. But again, hopefully you guys see that fail to reject and do not reject is the same. And I think Connect Math say do not reject rather than fail to reject. Again, it's just a habit of mine. When I learn fail to reject. So you will hear me say a lot fail to reject. Okay. Question?
I do have a question. I'm trying to see how, or the same question, you have two different answers.
They just mentioned this to say that if you fail to reject and if you do not reject, I mean, if you reject and you fail to reject, we haven't done the testing yet. So this thing here is just assuming that this is the result. We assume that this is a result. We assume that this is a result. That it's just all assumption right now. We haven't done any calculation, anything yet. So basically, they just give you, just imagine that you have two different studies, right? Two different studies, one study you reject and the other study you fail to reject. And again, how can this happen? Maybe up here you have, you know, they did not give you all the detail how many samples you collect. Maybe up here you collect 1,000 samples. So it's come out to be, the number come out to be good and then you reject. And down here, maybe you just collect 100 data and you don't have enough evidence yet because you only collect 100 data, right? So again, just don't look at this as a same problem. Imagine that we have two separate problem item here, okay? It's just that the reason I give you two exactly worded and then come out to two different conclusions is just to show you that this is the only two conclusions that you can come out. One of them is you reject, and if you reject, you have enough evidence. One of them is, the other one is you do not reject, and if you do not reject, you don't have enough evidence. That's it. That's all that we want you to see how to state your conclusion right now. Does that make sense?
Yes.
All right. So now let's take a look at this thing here, which is the last thing we have, which is this thing here, probably the hardest thing to graph is When we do this hypothesis testing, there are some consequence that will happen when we do this assumption. So let's take a look at this thing here. Is again, this is your decision, right? Your decision is, like I mentioned, your decision is you reject, you throw the H naught out, you reject the H naught, or you fail to reject the H naught, meaning you cannot throw the H naught out, right? So let's say that this is what we have is you either reject or fail to reject. And then the actual reality, the real result is this H naught is true or the H naught is false, right? We have two outcomes. You either throw them or kept, right? Throw them out or kept them. And the other thing is the H naught will be either true or false, right? You either be innocent or guilty, right? So looking at this thing here, looking at this item here, if we reject H naught, if we throw H naught out and H naught is false, then we make a correct decision. Because remember, we come in the assumption that H naught is true, but in reality it's false. And if it's false and we throw it out, well, that's a correct decision, right? Or vice versa. The other thing is we assume that H naught is true, and in reality it's true, and then we cannot throw it away. That is also a correct decision, because again, we fail to throw it out, and then it's actually is true. That's good, right? Because it's we did not make a mistake and accidentally throw something when it still is correct, right? So this is where it's a correct decision is when H naught is false and you happen to throw them out, reject them, then it's a correct decision. Or when H naught is true, H sub 0 is true, and then you do not throw them out, that is also a correct decision, right? So what is the consequence we have? Well, the consequence we have is for this testing is sometimes the wrong decision will be made. And that's what statistic is, right? That's where the margin of error came in, right? Because we are human, we make error, we make wrong decision, right? So there are two types of error. We say a type 1 error, which is what is type 1 error? Well, type 1 error is when H naught is actually true, but then you throw them out, you reject it, okay? So type 1 error happen when H naught is true and you reject it, right? So again, they say is we reject H naught when actually H naught is true, okay? So again, that's what type 1 error is, when H naught is true and then we reject them, we throw them out. The other one is type 2 error, which is the type 2 error occurs when we cannot throw out the H naught, but they are false, right? So again, type 2 error happen when H naught is false, but we cannot reject them. We fail to reject, we fail to recognize it, right? We fail to throw it away. So again, when it's false and you fail to throw it out, that's type 2. When it's true and you throw it out, that is type 1. Okay, so you look at this thing, you probably say, oh, what's type 1, type 2? Let's put this way. I think every statistic book, they mention this. So to make it realistic, type 1 error happen. If you're thinking in terms of the criminal trial, type 1 error happen when you send an innocent guy, right? Innocent until proved guilty. True, he is innocent. But you send an innocent guy to jail, okay? We reject his innocence. We throw his innocence out. We say, you guilty, you go to jail. So type 1 error is you send an innocent guy to jail, okay? That's type 1. When the item is true, but you throw it out, you reject it. That's type 1. And type 2 error happen. Type 2 error happen is when you send a criminal free, okay? Well, not send, you set a criminal free, meaning we cannot prove whatever the criminal crime that he did, we cannot prove it, right? But so we let him go, right? So again, when this thing here is false, meaning again, the innocent is false, meaning he's not innocent, but we fail to recognize it. we fail to recognize that he's not innocent, meaning you set an innocent, well, you set a criminal free. Okay, so that's type 2 is send a criminal out to society, right? And type 1 is you send an innocent guy to jail. Okay, everybody see type 1 and type 2. So which one is more damaging, right? Type 1 or type 2? You probably say, well, to whom, right? To an innocent guy, type 1 is damaging because he has to spend his life in jail for whatever reason that he did not do, right? The innocent guy go to jail. But as you can see, type 1 is only affect him, right? It doesn't affect us, right? Type 2 probably affect the society, right? If you send a criminal guy, set him free, and if he did the crime, he might redo it again, right? He might do some other crime again, which is affect the whole community or society. So again, based on that realistic, type 2 is affect more because it's affect the whole community. But the thing in statistic is because we deal with a sample, because we deal with the individual. So for us, statistic based on statistic item, type 1 is more important. So we would do a lot of type 1 testing, not type 2, because in reality, we don't know if he a criminal or not, right? Unless he commit another crime and then we tie it together, but we don't know that. So again, we more focused on this item, the individuality, rather than the more community-wise, okay? But anyway, question here with type 1 and type 2 error. Question on how to distinguish the type 1 and type 2 error. All right, if you don't have a question, let's take a look at this thing here. Let's say if you have this thing here, and again, this is just a setup. This is just a setup. They give you some tests, right? Some testing is made, and the result of the testing is here, and then the conclusion that we did. And now they ask you, is this a type 1 error? Is this a type 2 error? Or is this a correct decision? So what is the test here? Well, the test is made. The test is the mean is equal to 100. And again, the alternative or the alternate hypothesis is we say that the mean is not equal to 100. Everybody see that the null hypothesis, the mean is equal to 100. The null hypothesis, the mean is equal to 100. The alternate hypothesis, the mean is not equal to 100. And now we did some tests, and it's come out that the true value, meaning the result that we have is the mu is equal to 150. Okay, so again, we did some tests and it's come out that the mu is equal to 150. And now after you do that, this is the result that you have. You say H naught is reject. Meaning again, what does it mean? H naught is reject, meaning again, you throw away this item. You reject the H naught, you throw this thing away, okay? So looking at this thing here, they ask you, if you throw this thing away, is that a type 1 error, a type 2 error, or is a correct decision? Okay, so looking at this thing here, remember, if you throw this thing away, it tells you that you have enough evidence to support this thing right here, right? Meaning again, looking at this thing here, is this a type 1, type 2, or a correct decision? Any idea?
Is it correct?
It's correct decision, right? Yes, it's a correct decision because why? Again, do you agree that we came out and this number is not equal to 100, which is it's correct. That's my claim. My claim is not equal to 100. So as long as this number is not equal to 100, and then again, I throw this thing away, meaning I accept this thing here, which is this thing here will be a correct decision, which is again, right? Since the true value is 150, which is not equal to 100, which is that is what my claim is. And since we throw away, we reject the H naught, we throw this thing away, which is we accept this item here, which is, again, we say that we have enough evidence to support that the mean is not equal to 100, which is that is the correct decision. This thing is false and we throw it out. Because it's false, we throw it out, which is this thing is true. Everything good to go, right? So again, if you look at number 2, which is very identical, just different number, right? The null hypothesis is the mu is equal to 18, and the alternate hypothesis or alternative hypothesis is mu is bigger than 18. And then they come out and they found out that the mu is equal to 20, which is the mu is equal to 20, which is, do you agree that the mu is equal to 20, which is this check, right? The mu is equal to 20, this check, because 20 is bigger than 18. So we know that this is what we want, okay? But the conclusion is this. Well, the conclusion come in is H naught is not reject. You fail to reject them. You do not reject them. Meaning you do not throw this away. Okay, you did not throw this away. You don't have enough information to throw this thing away. So is this a type 1 error or type 2 error or a correct decision?
Type 2.
Type 2, right? Why type 2? Remember, type 2 is when this thing is false, but you fail to throw it away, right? When H naught is false, which is in this case, H naught is false because we did it and we see that this thing is right, right? But again, it's not equal to 20, it's not equal to 18, which is false. But somehow we fail to reject it, meaning the mistake is making here, which is, again, when H naught is false, but we do not reject them, that is your type 2 error. Okay, so again, when we do not reject H naught when H naught is false, when we do not reject H naught and H naught is false, is type 2 error. Fail to reject when they are false, when it is false. Okay, so again, looking at this thing here, that's the idea of this type 1 and type 2 error. Type 1 error is when H naught is true, but you throw them away, which is type 1 error. Type 2 error is when H naught is false, but you did not throw it away. You do not reject them. So that's type 2, which is in this case, that's type 2. Okay. And again, with positive of elimination, you probably see that number 3, the first one is correct decision. Second one is type 2 error. Positive elimination, probably type 3. I mean, not type 3. There's no type 3. Number 3 is type 1. Let me ask you guys, why is type 1 error? Why is number 3 a type 1 error here? Again, this is the 2 criteria, right? The 2 criteria is mu is equal to 3, mu is smaller than 3, and then you did the calculation, you do something, and you see that the mu is 3, which is the mu is 3, which is, do you agree that the mu is 3 is this item here, which is mu equal to 3? Agree? But then somehow you did it and you reject the H naught. Meaning, again, what does it mean reject H naught? Meaning you throw this thing away, right? You reject, you don't want to accept this thing here, right? So again, looking at this thing here, you throw this thing away. So now, do you agree that when this thing is true, but you reject it, right? They are innocent, but you reject the innocent, right? Which is, again, that's why this is a type 1 error, is reject the H naught when H naught is true, right? Everybody see that, again, the check is here, which is true, but then we still cross them out, right? We still say, no, we don't accept it, right? We throw it away, reject it. So again, that's the difference between type 1 and type 2 error. And again, hopefully, they always use that innocent guy go to jail is type 1, guilty guy set free is type 2. I don't know if that make it a little bit easier to comprehend, but that's what we have in type 1 and type 2. Somehow you have to graph in this thing here. And one thing is, ladies and gentlemen, 8.1, we haven't done any calculation right here. 8.1, the idea of 8.1 is we want to show you how the hypothesis testing work, which is basically we tell you the beginning, which is you have to state the h0 and h1, and then we tell you in the end you have to come up with a conclusion, which is you either reject h0 or fail to reject h0. And if the conclusion is reject h0, you will say that you have enough evidence to support whatever you want to support. If the conclusion is fail to reject or do not reject h0, then you say you don't have enough evidence to support whatever you want to support. Okay, so those are your two outcomes, which is again, the beginning you state them, the end you make a conclusion. And again, your conclusion might have a consequence, which is it might be type 1 or might be type 2, is depend on your h0, right? We haven't shown you the middle process. We haven't shown you how can you come up with the conclusion, right? So that's what we're going to do next week, ladies and gentlemen. 8.2, 8.3, and 8.4 is what we do in the middle. We have to state a hypothesis, but then what do we do in the middle so that we can come up with the conclusion? Okay, so again, today we haven't done any calculation. Today is just a small, small outline of what we will do, and then on Monday we will do in detail of what is actually the hypothesis testing is. Okay, but again, question here in terms of how to state the h0, the h1. Question on how to reject h0 and how do not reject h0, and question on type 1 and type 2 error. All right. If you don't have question, no, this is the end of 8.1. Again, like I say,